Today in lab we're going to be doing the crystallization experiment, which is number 3 in your textbook, and we're going to be doing parts A and B in lab today. So for part A, I've started with 0.3 grams of my impure sulfanilamide. It's this yellow looking substance here, and I've got about 6 milliliters of ethanol from a dispensing pump in my other Erlenmeyer flask here. So to start, I'm going to basically just put 1 milliliter. So on these Pasteur pipettes, if you just squeeze once, that's usually just about a milliliter. And I'm just going to go ahead and put that 1 milliliter of solvent into that Erlenmeyer flask. And then I'm going to start heating. And I'm going to start at 150 on the temperature setting and see how that goes. The key here is that I want to use as little ethanol as possible to dissolve the impure substance. Then I'm going to let it cool gently, and as it cools, hopefully really nice crystals will grow. So I've been heating for about 5 minutes now, and in total I've added 2 milliliters of ethanol to my flask here. Still, I've got lots of solid material, so I'm going to continue heating and adding a little bit of ethanol as we go. It's now been 10 minutes since I started heating, and I've nearly got all of that solid material dissolved. There's just a few little specks remaining in my flask. Okay, so it's been 12 minutes since I started heating, and all of my impure material has dissolved. I don't see any floaters, any solid material in my flask at all. So I'm just going to set this aside and allow it to cool slowly. And while it's cooling, I really don't want to disturb it. I'm just going to let it sit there until it comes back to room temperature, and hopefully we'll see some great crystallization. Finally, my crystals have grown out of my solution, so I can cool this a little bit further by putting it on an ice bath to ensure as much crystallization as possible, and then we can collect the crystals. Now I've got my crystallization flask in an ice bath, and I've also got the leftover ethanol on ice as well, because I want that cold ethanol solution to help clean the crystals once I've collected them. So this is a setup for collecting the crystals. I've got a filter flask with my Hirsch funnel. I've got a little piece of filter paper inside there to help catch all those crystals. And basically, once I turn the vacuum on, this will pull vacuum here and suck all the liquid down into the filter flask. When I do this, I want to try to get as much of these crystals onto the filter paper as possible. The first thing I'm going to do is, with my spatula, I'm going to sort of break these crystals up just a little bit. So now what I'm going to try to do is swirl and dump all in one motion. So swirl, 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 and then dump the whole thing. So that was pretty good. I got almost essentially all of the crystals. I got a little bit left over, and I can see them collecting and drying. So now what we want to do is take our cold ethanol and rinse out our Erlenmeyer flask. So once again, swirl, 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 and dump. So here I've got my crystals after I collected them from the Hirsch funnel. I just put them onto a watch glass to let them dry. The next step is to get a melting point and then determine the percent yield of how much you recovered. In part B, you're going to be using a Craig tube setup, and this is a full setup, and I'll talk more about how this is used later on. But this glass piece, this is what you're going to use in order to dissolve your impure material in the minimum amount of hot ethanol. So here's my setup for part B. I've got 0.1 grams of my impure sulfanilamide in my Craig tube, and I've got 3 mils of ethanol being heated up just in this test tube. So now that I started heating, I'm going to add about half of a mil of ethanol to my Craig tube just to get this going. So in this case, again, I want to add the minimum ethanol to dissolve this impure sulfanilamide mixture. To stir, just take your micro spatula and stick it in there, and you can just leave this in there and give it a stir every once in a while. So it appears that all of my solid has dissolved, so I'm going to just set this Craig tube aside and let it cool just like we did in part A. So my Craig tube's been chilling in the ice bath for about 10 minutes, so I'm ready to collect the crystals now. So how this is going to work is I'm going to take my other piece set that onto my Craig tube. Then I'm going to invert that inside of a centrifuge tube. So now this can go into the centrifuge, and you want to make sure that you counterbalance. So I've got an empty Craig tube set up on the opposite side, and I can set this for just about 1 or 2 minutes. If it's counterbalanced properly, it will just stay right on the table and won't shake around. If it starts shaking around all crazy, that means that it's not counterbalanced properly. You'll have to start over and make sure you counterbalance it. And what's happened is all of the liquid has been collected in the bottom of my centrifuge tube. So if I pull up on my wire, then I can see all of my product is collected in that Craig tube. So I can flip it over, and now in my Craig tube I've got my pretty much dried pure crystals that I just recrystallized. So again, I can collect these onto a watch glass, get my percent yield, and take a melting point, and that'll be it for today. For part C, again you're going to be doing a recrystallization, this time with impure fluorine. But in this case, before you do your recrystallization, you have to determine which solvent is going to be the best recrystallization solvent. So the choices are going to be methanol, water, and toluene. In order to determine the best solvent for the recrystallization, if you look at the technique on page 693, it'll walk you through the steps that you need to take. Basically, we're looking for a solvent that at room temperature has very little solubility, but at high temperature, near the boiling point of the liquid, has really good solubility. Once you've determined the best recrystallization solvent, go ahead and do a recrystallization using either of the methods that we used on day 1. Once you have your pure material, then you're going to want to take a melting point, and you can do TLC if you'd like to do that as well.